Hello guys, this is 5.2. We're going to look at the definite integral. So this is actually the formal notation definition of what we have seen in 5.1, which is adding up the little vertical rectangles area together and to estimate the area under the curve. So let's look at the formal definition. All right, so here we have the definition. Suppose f is continuous for a less than or equal to t less than or equal to b. So basically, if we have a certain domain for t between a and b, these two values, the definite integral of f from a to b is written as this. So this notation is the integral. All right. Now, if you have integral and then a and b, kind of like in these two places, then we say that this is the integral from a to b. Okay. Now this integral is the limit of the left hand or the right hand sum with n subdivisions of t between a and b as n gets arbitrarily large. In other words, if t0, t1 up to tn are the endpoints of each subdivision, then we can represent the integral by taking the limit of the left-hand sum or the limit of the right-hand sum. All right, so the left-hand sum and right-hand sum are the ones we talked about earlier, where you take the rectangle from the left-hand side of the interval or the right-hand side of the interval. And these sums are called the Riemann sum. Right? And f, the function, is called the integrand. A and b, they are called the limits of integration. Right? So a lot of terms in here, right? But no worries. Let's take a look at one example together. All right, so here's our first example. The values for a function f of t are in the following table. Estimate the integral of f of t from 20 to 30. All right, so we're going to estimate this by Riemann sum. All right, also known as the left-hand sum or the right-hand sum, right? Left or right sums. Okay. All right, so let's try to understand this table, right? So we have delta t, which is 2, right? Distance between each interval is 2. All right. So for the left-hand sum, we will be using these values, right? The left value of each interval. And for the right-hand sum, we'll be using the value on the right for each interval. Okay, so you can see that if it's left-hand sum, we are not including the last value, and for right-hand sum, we are not including the first value. All right, so let's do this. Left-hand sum is going to be 5 times 2, right? The left value multiplied by the width of the interval, all right? Plus 7 times 2, plus 11 times 2, plus 18 times 2, plus 29 times 2. All right, which will be 140, right? And the right-hand sum will be 7 times 2, plus 11 times 2, plus 18 times 2, plus 29 times 2, plus 45 times 2, which will be 220, right? So again, in this case, since our function is increasing, right, you can see that the left-hand sum is actually lower than the right-hand sum. So that will be an underestimate. And the 220, which is the value we found using the right-hand sum, will be the overestimate. Okay, so these are two estimation for the integral. All right, now of course we can find the average by adding these two, 140 plus 220 divided by 2, which will give you 180, right? So what we can say at the end is, okay, an integral from 20 to 30 of f of t dt is about 180. Okay, so this is just an estimation. Of course, we don't know exactly what it is, but we can do an estimation just by using the left-hand sum or the right-hand sum. All right, so here's another example. Example 4, we have the graph for the function f, and we want to find the integral from 0 to 6. All right, so integral of this line from 0 to 6 means we want to approximate the area under this line, this curve right here. All right, so that's actually split it into 3 intervals, right? So from 0 to 6, right, 6 minus 0 over 3 will give us 2, right? So this 3 comes from the n. So 2, that means each interval is going to be 2 units apart, right? So for example, this will be our first interval at 2, and then 4. We're gonna cut it up at 2 and 4, right? So our first interval is from 0 to 2, second is from 2 to 4, and the third is from 4 to 6. Now let's start with a left-hand sum. All right, so left-hand sum, we're looking at the interval between 0 and 2, and the left value is 0. We look at where 0 is, it's right here. So we form a rectangle using the width of each interval, which is 2. Right, like that. All right, so let's say this is actually 21. All right, and let's look at the second interval, 2 to 4. So the left-hand sum, so we're going to pick 2, which is right here, and then make a rectangle like this. And the y value here is actually 11. All right, and the last one, we're going to pick 4, which is right here. That's our third rectangle, and I think this is actually 5, exactly 5. All right, so let's look at our first rectangle. It has height 21 multiplied by width, which is 2, plus the second one, height is 11. 11, and width is again 2. And then the last one with height 5 and width 2. So when we add everything together, we get 74. Okay. Now let's look at the right-hand sum. All right, so let's do the same thing with this graph, but this time around we're going to do the right-hand sum. All right, so again, we have split them up at 2 and 4, making 3 intervals. All right, so the right-hand sum for the first one, 0 to 2, we're going to take the right-hand side, so it's 2, and then make a rectangle in the first interval. And this value, I believe, was 11 that we used. Okay, and the next one, between 2 and 4, right-hand sum at 4. Okay, make a rectangle. And then the last interval, which is 4 to 6, the right-hand sum at 6. And the height of the last rectangle, it's 3. Right here, 3. All right. So you can see that for using the right-hand sum in this case, this is going to be an underestimate. All right, so starting with the first one, 11, height is 11 times width 2. And then the second rectangle plus 5 times 2. And the third one is going to be plus 3 times 2. And then that gives us 38. Okay. So in this case, for this curve, the left-hand sum will be an overestimate, and the right-hand sum will be an underestimate. All right, and then lastly, to get a better approximation, let's find the average. Right, so 38 plus 74 over 2, that gives us 56, right? So we can say that the integral from 0 to 6 of f of x dx is approximately 56. Okay. All right, so let's look at another one from graph. Basically an overview. We're not going to do any calculation here. All right, so we're doing the same thing with some function g of x, taking the integral from 0 to 6. All right, so we want to estimate the area under the function g of x from 0 to 6. All right, so the first one, let's see. So these, we can see that it's being cut into 3 intervals, right? So n is equal to 3, right? And each interval has a unit of 2, right? Because we're looking at from 0 to 6, right? So when we cut into 3 equal pieces, each one of them have width of 2. All right, so let's look at the first one. Which one is this, the right-hand sum or the left-hand sum? All right, so you want to look at this rectangle right here in the first interval. Which point do they use as the reference point? The left or the right? Right, in this case, we're using the right point as a reference point, right? Right here as well, making a rectangle like that. And then the last one right here. All right, so this is actually the right-hand sum. Right, and then you can look at part 2, and that will be the left-hand sum, right? Left of the interval, and left of the interval, right? So right-hand sum and left-hand sum determines, do you use the left point in the interval or the right point of the interval to construct the whole rectangle, right? If you pick the right point as your reference point to make the rectangle, like in part 1 here, then this will be a right-hand sum. If you pick the left point in the interval to make the rectangle, then that makes it the left-hand sum. All right, so we answered part A. Do the rectangles represent left or right? The first one is right, second one is left. Now, do the rectangles lead to an upper or lower estimate? All right, so let's look at the first one. When we use the right-hand sum, notice that the rectangles are all higher than the actual function, right? So this will be an overestimate, right? Because you have more areas than the area under the curve. Whereas second part, notice that the rectangles, they are strictly below the graph. So we have these little y triangles left, right? So in this case, this will be an underestimate or lower estimate, right? Because the value you get from the area of the rectangle is lower than the actual area under the curve. All right, part C, what is the value of n? N is the number of intervals you have, so it's 3, right? We have 3 intervals in each one of them. What's the value of delta x? Delta x represents the width of each rectangle, right? So each rectangle is 2, 2, 2. Right here we have 2, 2, 2, and then also for part 2 we also have 2, 2, and 2. Right, so delta x is equal to 2. Okay, so hopefully this is a little more clear than 5.1. Now 5.1 was just a quick introduction, and 5.2 is where we really get into the details of the adding the sums of the rectangles to estimate the area. All right, thank you guys very much. Hope this was helpful, and I'll see you next time.